Hello and welcome. In this session, we are going to create, evaluate, and score a churn prediction model. So, the scenario is to build a model to predict whether the bank customers would churn or not. The churn rate, also known as the rate of attrition, refers to the rate at which the bank customers stop doing business with the bank. So the main steps involved would be to install the custom libraries, load the data, understand and process the data through exploratory data analysis, and demonstrate the use of Fabric Data Wrangler feature. Then train the machine learning models using scikit-learn and LightGBM and track the experiments using MLflow and Fabric Autologging feature. Then we are going to evaluate and save the final machine learning model. Then we are going to demonstrate the model performance via visualization in the Power BI. So let's get started with the practical. So first thing, we need to create a workspace. So go on to Microsoft Fabric Home, select workspaces and click on new workspace. Let's give this workspace a simple name, Churn workspace. And in the advanced license mode, we are going to select trial and apply. So we are just doing the prerequisites right now. And the next prerequisite is to create a lake house. Click on new item inside the workspace and let's search for lake house. And next we need to give a name. Let's just give it lake house and click on create. So we will be downloading some data from a public blob from Azure and then storing the data in the lakehouse we just created. So next step is to create a new work notebook. So go back to the workspace and go into new item and let's search for notebook. You can select any of the notebooks from here. All will perform the same purposes. Let's just select a notebook and this will load a notebook. So all the prerequisites are almost done. Next, we just need to add the lakehouse to our notebook. So we can select add data sources or we can just go to lakehouses and click on add and existing lakehouse without schema and add our lakehouse. Okay, so name was fine. Still, it's all right. So our lakehouse will be added and currently there are no tables or files. So now will come the actual implementation. The first thing we are going to do is install some custom libraries. So when developing a machine learning model or doing ad hoc data analysis, you may need to quickly install some custom libraries like we are going to install IMB-learn in this notebook for the Apache session. So to do this, we have two choices. We can use the inline installation capabilities using percentage pip or percentage conda, etc. to quickly get started with the new libraries. So note that this installation option would install the custom libraries only in the current notebook and not in the workspace. So let me just show you the commands for how we can do it using percentage pip. So we just use percentage pip and then we will give the library name. Or the percentage conda is also the same. We just give percentage conda here instead of pip. So that's what it is. So alternatively, you can use Fabric environment install libraries from public sources or upload custom libraries to it. And then your workspace admin can attach the environment as the default workspace. So all the libraries in the environment will then become available for use in any notebooks and Spark job definitions in the workspace. So in this notebook, we are going to install the IMB learn using percentage pip install. So note that the PySpark kernel will be restarted after the percentage pip install. So we will need to install the libraries before we run any other cells. So let's just give percentage pip install and then the library name. We are using IMB learn, and let's connect a simple standard Spark session. This will be the compute engine for running our code cells. So let's wait for the Spark session to start, and then we will run this code cell. So the standard Spark session is up. So let's select run cell, and this will install the IMB learn library in our notebook. So the command executed successfully. Next, we are going to load the dataset. So before that, let me tell you about the dataset. So the dataset is churn.csv, and it contains the churn status of 10,000 customers along with 14 attributes that include credit score, geographical location like Germany, France, Spain, gender, age tenure like the number of years the person was a customer at the bank, account balance, estimated salary, number of products that a customer purchased through the bank, credit card status, like whether or not the customer has a credit card, active member status, whether or not the person is an active bank customer or not. So the datasets also includes row number, customer ID, and customer surname columns. The values in these columns should not influence a customer's decision to leave the bank. A customer's bank account closure event defines the churn of that customer. The dataset exited column refers to the customer's abandonment. Since we have little context about these attributes, we do not need background information about the dataset. We want to understand how these attributes contribute to the exited status. So out of those 10,000 customers, only 2,037 customers, like roughly 20%, left the bank. Because of the class imbalance ratio, we recommend generation of synthetic data. So confusion matrix accuracy might not have relevance for imbalance classification. We might want to measure the accuracy using area under the precision recall curve, or AUPRC. So we are going to download the dataset and upload to the lakehouse. So let's define the parameters. So let's create a new cell, and let me give you the code to upload the dataset. So this is the code. In the first line, custom data equals to false. So if this was true, the dataset has to be uploaded manually. And now is sample equals to false. So if true, so if this was true, it will use only the sample rows of data for training, or otherwise it will use all the data. So if is sample is true, we are going to use this number of rows for training, which is inside sample rows equals to 5,000. Then this is the location, and we are going to use the data folder with the files. So let's run this. So make sure before running this code, you have a lakehouse attached to your notebook, and the failure to do so will result in an error. So mine executed successfully. So this code will download a publicly available version of the dataset and then stores that dataset in the Fabric Lakehouse. So the next set of code is this. So this code will check if the directory exists or not, and if yes, it will download the files into our lakehouse that is attached to the notebook. So here we are defining the remote URL. So it will download the demo data files into the lakehouse if they do not exist inside our lakehouse. And so the default lakehouse will add the data to the lakehouse and restart the session, and it will give the output message as downloaded demo data files into our lakehouse. So let's run this. and it will take just a few seconds, and you can see downloaded demo data files into our lakehouse. So let's refresh the files folder, and here we will have, let me, so after refreshing the files folder again, we got the data, and here we have the churn folder and raw data inside it. So now we are going to import some other libraries, like let's import time. So and then give ts equals to time dot time. This was in the next line. So we are gonna start recording the time needed to run the notebook. So let's just import these libraries quickly. And the next thing, we are going to read the raw data from the lake house. So the next set of code will create a df to read the raw data files and adds more columns for different date parts, like creation of the partition delta table for this information. So let me give you the code. So this is the code to create the DF, and it is using the CSV file inside file slash churn slash raw slash churn.csv is the name of the file. So here we have the churn.csv file. So, and it is inferring the schema, meaning that it will automatically, the Spark session will automatically try to guess what is the schema type, like if it is integer values, string values, etc. And the header equals to true or header true means that the first column will be considered as header. So now let's create the df, and this will take only a few seconds. Next, we are going to create a pandas df. So we will be converting the df we are just creating to a pandas data frame for easier processing and visualization. So let's add a code cell and give df equals to df dot to pandas, and this will convert our code cell, sorry, data frame to pandas data frame. Next, we are going to perform some exploratory data analysis. So we can explore the data with display function and calculate some basic statistics and show chart views. So we have to first import a few required libraries for data visualization, like Seaborn. So Seaborn is a Python data visualization library, and it provides high level interface to build visuals on data frames and arrays. So let me give you the import statements. So these are the import statements. We are importing Seaborn and matplotlib and matplotlib ticker and some numpys, pandas, and iterative tools. So let's run this. This will take a few seconds because the libraries are pretty big. And next we are just displaying the df. So let's give display df, and let's also get the summary. So this will display the data frame we have created and also give the summary, like how many rows, columns it has. So let's wait for it. So here you can see we have the summary. So let's select a row. So it will also give the statistics of that row. And we use infer schema to get the schema. So it automatically tried to guess the schema type, and most of these are integer values or float values, just surname, geography, and gender, and these are strings. So now we are going to use data wrangler to perform the initial data cleansing. So let's launch the data wrangler directly from the notebook to explore and transform pandas data frame. So on the top ribbon, select data wrangler drop down, and it will ask us or prompt us to browse the activated pandas data frame. So we are going to select the data frame, and this will open the data frame in a data wrangler. So now in the data wrangler, it will show a descriptive overview of the data panels like the ones you can see here. You can see row number, customer ID, surname, credit score, and all of the other columns as well. So this overview includes information about dimension of the data frame, like any missing values, etc. And you can use data wrangler to generate the script to drop the rows with missing values and duplicate the rows and the columns with specific names. So now let me give you the script to drop the duplicate rows and drop the rows with missing data. So in the new operation, let's first clear everything. Okay, if you start writing, it will clear. We are going to define clean underscore data and give df inside it. So the df we just created, and then we are going to give df dot drop na, and inside in place equals to true. So this is the code to clean the df. So here we are. So here we are using df.drop na. We are dropping the rows with missing data across all columns. Then df.drop duplicates, as the name suggests, we are dropping the duplicates in the rows in dropping the duplicate rows in columns like row number and customer ID. And then we are using df.drop to drop the columns named row number, customer ID, and surname, and then returning the df and storing it under a new df named df underscore clean. So let's apply. So this will apply the custom operation, and then we are giving another custom operation. So okay, let me start typing. Df is underscore sample colon df underscore clean equals to, okay, what happened here? Let me type it again. Df underscore clean equals to df underscore clean dot limit by sample rows. So if a sample is true, it will only use the sample rows or sample rows of the rows for training. So let's apply. Next, we are going to determine the categorical, numerical, and target attributes, which is basically just determining the attributes. So let me give you the code. So now let's go back to the notebook and we will be performing some operations to clean the data. So here, so let's add a new cell and let me increase the size. So next code will be to clean the df. So we are going to define a new clean underscore df and use the df we have, and then give the commands df dot drop na. So this will drop the rows with missing data accordingly, and we are giving in place equals to true equals to true. So let me just complete this cell. So this is the code. So the first line or df dot drop na or drop na, this will drop the rows with missing data. And then df dot drop duplicates, as the name suggests, it will drop the rows in columns row number and customer ID which have duplicate values, and then we are dropping some columns like row number, customer ID, and surname which are irrelevant for our use case. So let's run this cell, and then we are finally storing the clean df in a new name or under a new name clean df underscore clean. Now let me give you the code. So if is sample So we are using the sample rows. So if the sample is true, it will only use the sample rows for training the data set. So let's run this. Next, we are going to define and determine some attributes. So we are determining the categorical, numerical, and target attributes. So let me give you the code for that. So this is the code. So we are determining the dependent or the target attribute. So here we are determining the target attribute. Then we are determining the categorical attributes using categorical variables and then printing the categorical variables. And then after that, we are determining the numerical attributes. So let's run this code cell. So here you can see it gave us the categorical variables like geography, gender, number of products, has credit card or is an active member or not. And then the numerical variables like credit score, age, tenure, balance, and estimated salary. Now, what we are going to do is show 5 number summary. So, show 5 number summary is minimum score, first quartile, median, third quartile, and maximum score for the numerical attributes by using box plot. So, we are going to use SNS or Seaborn for this. So, let me give you the code to create the box plot. So this is the code. We are setting the scale to 0.7. And what we are doing here is visualizing and comparing the distribution and central tendency of numerical attributes and giving color equals to something like green and font size as 12. So let's run this cell. So here you can see the box plot. So the credit score and age and tenure and balance, count balance, and estimated salary. Now let's add another code cell. So now what we are going to do is create a subplot for our data. So let me give you the code for that. So using this code, we are displaying the distribution of exited versus non-exited customers across the categorical attributes in a subplot format. So let's run this cell. Okay, there is an error. Let me check. So now after introducing proper 2D indexing using ind//3 and ind%3, we can finally view the results. Now what we are going to do is use a histogram to show the frequency distribution of the numerical attributes. So let me give you the code for that as well. So here is the code. And this is just the title for that. Now let's run this. So this will give us the histogram distribution of the data. So next we are going to perform feature engineering. So the feature engineering will generate new attributes based on the current attributes like new tenure, new credit score, new age score, and like balance score and salary score, etc. Now let me give you the code for one and I will complete it all df underscore clean, then giving new tenure, then equals to df underscore clean by using tenure and by df underscore clean and age. So in the similar manner, let me complete all the others as well. So this is the code. Now let's run this. So this will create new attributes based on current. Okay, there is an error. Let me check. So here I have corrected the code. So we are just ensuring that tenure and age are numeric and then handle the null values. And now after that, we are performing the new calculations. So let's run it. Next, we are going to use data wrangler to perform one hot encoding. So data wrangler can also be used to perform one hot encoding. So to do so, let's reopen the data wrangler, but this time we are going to select the new df, that is df underscore clean. So this will give us the df underscore clean. And now let's wait for it to load. Now in the operations, let's expand formulas and we are going to select one hot encode, and a new panel will appear, and in the list of columns we are going to select geography and gender. Let's close it. So this will automatically generate the code. So you could copy the generated code and close the data wrangler to return to the notebook and then paste it into a new cell. Or you could select add code to notebook after selecting apply. So first let's select apply, and here we have one hot encode. So let's add this code to notebook, and in the end you will automatically find the newly generated code. Now let's run this code cell, and it executed successfully and displayed the new clean 1 df. So let me give you the summary of the observations from the exploratory data analysis. So it says that most of the customers are from France, comparing to Spain and Germany, while Spain has the lowest churn rate comparing to France and Germany. And most of the customers have credit cards, and there are customers and whose age and credit score are above 60 and below 400 respectively, but they cannot be considered as outliers. And very few customers have more than two of the bank's products, and customers who are not active have a higher churn rate. And gender and tenure years do not seem to have an impact on the customer's decision to close the bank account. Now let's create a delta table for the clean data. So let's add a new code cell and let's give the table name equals to df underscore clean and spark df. So let me just complete the code. So this is the complete code, and here we are generating a Spark data frame using pandas and storing it under a new table. So let's run this. So our Spark data frame has been saved to a delta table. So let's explore lakehouses and refresh. So here we will have our new table named df underscore clean. You can see it's still loading, so not to worry. Next, we are going to train and register the machine learning models. So we are going to train multiple machine learning models to select the best one in order to predict which bank customers are likely to leave. So we will run random forest and LightGBM models, use Microsoft Fabric's native integration with MLflow framework to log the trained machine learning models, and use the hyperparameters and evaluation metrics. Then register the trained machine learning model and assess the performance of the trained machine learning models on the validation dataset. So you can either create a new notebook and attach this lake house to that new notebook, or you can just follow along in the same notebook we have been using up until now. So what I'm going to do is just give a small heading and then follow along with the ML operations to train the machine learning model. And now the first thing we are going to do for training the machine learning model is install some custom libraries. So we will be installing imbalanced-learn, which is imported as imb-learn using %pip install. So imbalanced learn is a library for synthetic minority oversampling technique, or SMOTE, which is used when dealing with imbalanced datasets. So the PySpark kernel will be restarted after percentage install. So we need to install this library before running any other cells for the machine learning model. So let's give the code pip install imb learn. Let's run this. So because my notebook has had it already installed, so it will give us the requirement already satisfied. But if you're using a new notebook, you should run this command. Now we are going to load the data. So prior to training any machine learning model, we need to load the data into we need to load the delta table from the lakehouse in order to read the clean data that we created. So let's import pandas as pd and let's give the seed and df underscore clean equals to again underscore clean spark dot read dot format. We're giving delta. Well, I'm giving these commands because you might have created a new notebook. I do not need to run this. I just follow along or not. Tables slash df underscore clean, then pandas. Okay. So now let's run this code cell. Next, we are going to generate experiment for tracking and logging the model using MLflow. So I'm going to demonstrate how to generate an experiment, specify the machine learning model and training parameters as well as scoring metrics, and then train the machine learning models, log them, and save the trained models for later use. So let's add another code cell and import MLflow, and let's give the experiment name equals to bank churn experiment. So let's run this. So extending the MLflow autologging capabilities, autologging works by automatically capturing the values of input parameters and output metrics of a machine learning model as it is being trained. So this information is then logged into your workspace where it can be accessed and visualized using the MLflow APIs or the corresponding experiments in your workspace. So all the experiments with their respective names are logged and you will be able to track their parameters and performance metrics. So now let's set the experiment and auto logging specifications. So we are going to use MLflow for that. Set experiment, then inside here we are going to give the variable as experiment name and then MLflow dot autolog, and here give exclusive equals to false. Now let's run this. So the experiment with name and it will automatically create a new experiment. So next we are going to import scikit-learn. So there was just a spelling error. Now we are going to import scikit-learn and LightGBM. So with your data in place, we can now define the machine learning models and we will be applying random forest and LightGBM models in this notebook. So we are going to use scikit-learn and LightGBM to implement these models. So let's import the required libraries. So these are the libraries we are importing. So let's run this and add a new code cell. So now we are going to prepare and train and validate our validate and test our data set. So we are going to use train test split function from the scikit-learn to split the data into training, validation and test sets. So we are going to use the clean df. Let's give underscore clean and yep. Similarly, let me just complete the code. So here we are splitting the dataset into 60%, 20%, and 20% for training, validation, and test dataset respectively. And then we are performing the train test separation and the train validation separation. So this one is for train test separation and this one is for train validation separation. Now let's run this code. Next, we are going to save the test data into a delta table. So we are going to create a new table using table underscore name equals to, let's give the name as df underscore test. And we are going to give df underscore test equals to spark dot create data frame and x underscore test. Then we are going to give the write mode df underscore test dot write dot mode, and the mode we will give is overwrite. Then we have to give the format, so the format will be delta because we are storing it in a table or a delta table. Then we are going to save, so we have to give the path, so we have to give it like f with and then a variable table name. Let's close this. And then we are just going to give a small print statement. Table, and let's also print the table name. We have to give table underscore name. Okay, we have to give it inside the double quotes. That's what the issue was. Now let's run this. So the Spark test data frame saved to a delta table named df underscore test. So let's check. Currently we only have df underscore clean table. So let's refresh and we will get the df underscore test. So here you can see. Next we are going to apply SMOTE to the training data to synthesize new samples for the minority class. So the data exploration showed that out of 10,000 data points corresponding to 10,000 customers, only 2,037 customers, or around 20%, have left the bank. This indicates that the dataset is highly imbalanced. The problem with imbalanced classification is that there are too few examples of the minority class for a model to effectively learn the decision boundary. SMOTA is the most widely used approach to synthesize new samples for the minority class. Now let me give you the code for that. And we are going to import counter and SMOTE. So this is the code. Note that SMOTE should only be applied to the training dataset. You must leave the test dataset in its original imbalance distribution in order to get a valid approximation of how the machine learning model will perform on the original data, which is representing the solution in production. And now let's run this. So you can ignore these MLflow warning messages that appear when you run this cell. So here you can see the run executed successfully. So if you see a module not found error message, so you missed running this IMB learn library cell, or the session expired and was recreated again. So you need to install this library each time you restart the notebook. So if you get an error of module not found, so you should go back to the first cell in this notebook and rerun all the cells starting from the first. Next, we are going to train the model. So let's give a small heading first. Okay, let's first create here train model, and we are going to use MLflow to train the model. So let me give you the code for that. So we are going to be using random forest with a maximum depth of 4 and 4 features. So this is the code to train the model using random forest. First, we are registering the trained model with the autologging. Then in here, we are passing the hyperparameters. Then using run ID and run.info, we are capturing the run ID for the model prediction for later. And this commented code is for imbalanced training data, and the one directly below it for the is for the balanced training data. So now let's run this code cell. Next, we are going to train the model using random forest with a maximum depth of 8 and 6 features. So the code will be pretty similar. So let's wait for it to run and then we will move forward. So our code executed successfully and a new run has been created. Now this is the new code for maximum depth at 8 and maximum features at 6. Let's run this. After this, we are going to train the model using LightGBM, and let's wait for it to run. Then we will move forward with LightGBM. And our run executed successfully, and you can see the run ID is displayed. Next is the LightGBM. We are doing pretty much the similar things. At first, we are registering the trained model with autologging. Then we are capturing the run ID for the model predictions for later. So this commented code is for imbalanced training data, and the one directly below that is for balanced training data. So now let's run this code cell as well. So here you can see a new run. Okay, there is an error.